So again, continuing on with our talk on accuracy and precision, it's kind of these significant figures. How do we report them? And how we can report them is through scientific notation. Scientific notation allows us to put numbers in quantities between 1 and 10. Why? It makes our brains easy. It's easier for our brains to understand this. You've seen 10 of something because most of us have 10 fingers. Okay? It's easy for us to understand that. Looking at a number of like 8 quadrillion, we would have a very hard time visualizing that. So, ways to get around that is you convert that really big number into a small reasonable number and then another number that just indicates it's really big is what it comes down to. So when we see a number such as 1, we've seen that before. Okay? The 2 here just indicates how big it is. And so are able to understand the numbers just a little bit better. So positive exponents mean the decimal place is moved to the right, not many times. If there's open spots, we fill them with eggs or zeros. I always look at as the example of positive exponents. There's usually something that you can think of if you have a bank account. Many of us would probably like to have $10,320 in our bank account. We would see that as a positive thing. Therefore, the exponent should be positive. As we add these little loop-de-loops in here, indicates how many. 4 different colors, because we're visual learners, many of us. Many of you have probably seen this explained a similar way, where they just kind of just do the same color and they loop it all the way back. I like to try and change it up to the colors so that you can see it, and so that it makes sense. If there were empty ones, such as the case here, we added this 0 because it needed to fill the basket of eggs. Fill it in. So positive exponents, large numbers, because we would want that large number in our bank account. Negative exponents means the number gets smaller. And again, we tend to fill the loops or the baskets with zeros. Now, many of us would probably not want to have 286. That would even be like, not even a full penny in our bank account. Fractions of a penny. It's like what you're earning interest on, right? Negative numbers in the bank account is something we would not want. We would see that as a negative thing. So, negative exponents, small numbers. That's normally how I'm going to ask that question when it comes to which way do I go. A lot of it will come down to I want to have large numbers in my bank account. I would see that as a positive thing. I don't want to have small numbers in my bank account. I would see that as a negative thing. So a negative exponent. And it comes down to that same thing, is that how do I know which way to go? Well, is it negative? That means the number needs to get smaller. If it's bigger, if it's a positive, that means the number needs to get bigger. Now, last week, we said that these zeros here do not count because they're to the left of that non-zero digit. This is where scientific notation can help us report only the things that are significant, that mean something to us. The fact that it's a -3 just tells us that it's small. And it gets 3 loop-de-loops. Now, when we do the reverse, if it's a big number, we need to have that it's a positive exponent. Again, using the number in the bank account as the analogy is not a bad thing. We have to use what helps us. And most of us like money. Therefore, positive amounts, positive money. Now, we don't have a decimal place originally here, but there's an imaginary one. That's what we move. Now, sometimes I've seen students write this. (29.836) times 10 to the third. Technically, nothing wrong with that. Okay? But practice tells us to keep the number between 1 and 10. Is 29 is not a large number, easy for us to comprehend. It's just technicalities. Some people have counted it wrong. I understand what you're saying with that. So it is kind of a little bit of a, well, yeah, it's correct, but not completely. So sometimes you might find it might automatically be marked wrong in an assignment, but that's kind of the why, is because 2.9836 times 10 to the fourth is the technical correct answer. Even though 29 is a small number, a lot of it will come down to personal preference of the person grading. I don't like to use numbers bigger than 50, pretty much. Just because. 10 is what they say, though. If the decimal point is small, you got to move them back. An example of this would be, how do you have this number here on the left shown only with its significant digits? And that's using scientific notation. Getting rid of those non-significant zeros. How do we determine whether it's a positive or a negative? It all comes down to small number, not fun to have in a bank account. Big number, positive thing to have in the bank account. So, let's try some of these out. Converting back and forth. Now, I've always asked, sometimes students don't write examples down in their notes, and I always question the why. If you get to use your notes in class, wouldn't having examples in there be a good idea? Crazy sometimes. These things that Peterson thinks of. All right. I might not do different colors for loop-de-loops, but I'm definitely going to do different colors for the actual loops. All right, let's see here. 6.82 times. I'm going to get rid of that part. Okay. I need to move this decimal place how many times? Someone says 5 by a show of fingers. One, 2, 3, 4, 5. The arrow points to where the decimal needs to go. We fill our basket full of eggs. We rewrite our number. And then we ask ourselves the question, does my answer make sense? Some of you will probably say, no, it never makes sense. My numbers never make sense. If my number here is positive, that means my answer should be bigger, because that's what we want, right? We want that much money in our bank account. Because, who wouldn't want that in their bank account? Or buried underneath a tree in a shoebox or whatever, however you store your money. Okay. That's part of the evaluating your answer. The next one. Negative, that means the numbers move what direction? To the left. One, two, 3 times. Why 3? Because there's a 3 right there. The new decimal place goes on the tip of the arrow. We fill the empty spots with eggs. Now you get into the philosophical debate. Do I put the 0 in the front? That's the big question, isn't it? $1 million question. Does it matter? A lot of it will depend upon the professor or whoever is grading your assignments. If you can tell me, and this is maybe I'm wrong as a teacher, but whatever. If you can tell me that you have this here, to me, it shows you're figuring some things out. This 0, is it important? Yes, it is technically important. When I was in college, I had a historical geology professor that required that 0 to be there, or the whole thing was wrong. So what do? I put it there because I know I'm supposed to just put it there. But if I see students showing me these 2 here and putting the decimal in the right place, I'm okay. Would it be an easy fix for you if you ever go on to bigger and better things to just add that other 0? Yes. It's small potatoes in my mind. There's bigger fish to fry. Just worry about you getting it moving in the right direction first. Ultimately. Okay. Let's evaluate our answer. It's small. Is it supposed to be small? Yes, because this is negative. Therefore, it makes sense. The next one. Usually always confuses students. Why would you do that? Because we like throwing curveballs at you every now and then. So, we move it back 1 place. It's small. It might not seem like a lot, but at times it's necessary. Usually, this way is pretty easy for students. Sometimes, the next way, we're going the other direction, not as easy. So, let's try that out. And just for humor, how many significant digits does A have? 5. They're all non-zeros, right? They're all cookies. They're all significant. We need to put that into scientific notation. They move our imaginary decimal place, even though it's not there. 1, 2, 3, 4. Put my decimal place in the imaginary at the top of the arrow.
Would it be okay to do just 3 there? Or does it have to be 4?
Again, it comes down to, I know what you're talking about if you're trying to show 12.345 times 10 to the third. I know what you're doing. Okay. And since I defined it as numbers between 1 and 10, that's why I try to teach it at least there. Some people count it out loud as you do the loops. Some people just then come back and go 1, 2, 3, 4. And why is writing the loops helpful? How many of you ever forgot a number? Now this, but if you do show the loops, you have your work essentially shown to you, so you can then just count it again.
Can it be -4?
Great question. Is it a -4? Well, would $12,345 in your bank account be a positive thing or a negative thing? Positive. Therefore, sign would be positive. B. How many significant digits are there in B? Thinking back to our rules of significant digits, all non-zero digits are significant. Well, the 6, 1, the 1, and the 2. Do we have zeros in between non-zeros? No. Zeros to the left of the decimal place are considered to be insignificant. They just show us that it's really small. Here we go. And therefore, we want to, in a way, try to figure out a way to get rid of them. That's what scientific notation does. It gets rid of them. And so that's what we do. We move it 1. Oh, yeah, well, let's just do it. 2, 3, 4. Rewrite it out. Decimal goes at the top of the arrow. Positive or negative? Would this very small number be a good thing to have in your bank account? No. Therefore, -4. In C, how many significant digits are there in C? Well, if we look at our ruler rounding, we got 2 non-zero numbers. Those count. We got a 0 in between non-zeros, so Oreo rule, right? We don't have any numbers in front of the 1, so the not left rule doesn't come in. We have a lot of zeros after the 3, but is there a decimal place there? I don't see one. Remember rule 5, large numbers without a decimal place, these zeros are insignificant. Now when we do scientific notation, we move our imaginary, quotation mark and quotation quotes there, our imaginary number. So So I'll rewrite my number here so it's a little easier to see. I move my imaginary decimal 1, 2, 3, 4, 5, 6, or do I go 7? Doesn't matter. Not really. Okay. I'm going to go with the 7. Now, putting very, very large numbers into scientific notation gets rid of these insignificant zeros. Here we got rid of these insignificant zeros. Now we got rid of these insignificant zeros. Now, a lot of this can be achieved using your calculator, if you know how to use it. My suggestion to any and all students is to get an ACT approved calculator. An ACT approved calculator are usually the cheap ones. Okay? Ones that are expensive that will have the QWERTY keyboard are not ACT approved. Your iPad technically is not an ACT approved calculator, even though many of us will be using it on our homework. An ACT approved calculator can be a TI-84 plus color, whatever crazy thing you want to have. But it can be as simple as the TI-30X2S. And the S just means that it's solar. Okay. One that's not, another one that's not is like the TI-89, and even the 89 plus. It's because you can program it. It's technically not. The TI-83 plus is pretty common base one. There's also, I think there's like one or two, maybe one Casio that's not. But a lot of them will do this for you. You just have to know how to talk to it.